Section 3.5 is about systems of equations in three variables. Before we get into that, I'd just like to review a little bit about equations in general. For instance, if we have an equation in one variable, let's say 3x plus 2 equals 14, when we solve this equation, we subtract 2 on both sides, and so it becomes 3x equals 12. We divide both sides by 3, so x equals 4. Now, what does a solution set look like? Well, it's a point on a number line. Here's a number line. Here's 2, 3, 4, 5, 6, etc. So the solution set is simply one dot on a number line. Now, let's say we have an equation, linear equation in two variables. Let's say we have 3x plus 2y equals 6. What does that solution set look like? Well, we know the solution set would be in the xy coordinate plane. It would be a line. So it would be from that 1, 2, 3, 1, 2, and 3. So I go from here to there. So the solution set is a line that looks like this. Every ordered pair on this line would be a solution to the given equation. Then when we have systems of equations like 3x plus 2y equals 6, and let's say the other equation is y equals x, so there would be, the graph would be like this. This is y equals x. And this was 3x plus 2y equals 6. Then the solution set to the system would be this point here. So the point of intersection is the ordered pair 6/5, comma 6/5. Okay. So now when we have a system of equations with three variables, and we're going to look at one in just a moment, but just in principle, so here the solution set was a point. Here the solution set to one equation was a graph of a line. The solution set when we have a system of equations was a point. So when we have three equations and three variables, the solution set for one of them, in other words, if we have ax plus by plus cz equals d, for example, 2x minus y plus 3z equals 9. Not that this is going to be very accurate, but we are now looking at a three-dimensional situation, three-dimensional coordinate system, x and y and z. Now this is not the scale, but the solution set to this equation would be the graph of a plane, kind of like this. And of course it would extend in all three directions, just like a line extends in both directions. And then when we have a system of equations with three variables, then we have three planes that intersect, or perhaps they don't intersect, depending on the situation. Okay, so we go from point to line to plane. So a linear equation in three variables is an equation equivalent to one of the type ax plus by plus cz equals d. A solution of a system of three equations and three variables is an ordered triple x, y, z that makes all three equations true. The first step is to eliminate a variable and obtain a system of two equations and two variables. And we know how to solve that system of equations. We've done this in the previous sections. But here are the general steps for solving a system in three equations and three variables. Number one, write all equations in the standard form ax plus by plus c equals d. It looks a little bit unfamiliar, but you'll see in just a moment how it really looks when we're doing it. Clear any decimals or fractions. That's optional, but it's a real good idea to do that. Choose a variable to eliminate. So in other words, we use the elimination method, and we do that one step at a time typically. Then use any two of the three equations to eliminate that variable, getting an equation in two variables. Next, use a different pair of equations and get another equation in the same two variables. That is, eliminate the same variable that you did in step 3. Again, that sounds a little bit abstract, but we'll do it in just a moment and you see how it looks, how it really works. Then solve the resulting system. In other words, a pair of equations that will give you two of the numbers, and then use any of the original three equations to find the third number. Okay, so I think once you see how it's done, all the steps that you saw here will make a lot of sense. So here are our three equations. Solves the system. Don't forget to check. So we have 4x minus y plus z equals 6, minus 3x plus 2y minus z equals negative 3, and 2x plus y plus 2z equals 3. So let me rewrite these equations. 4x minus y plus z equals 6. And minus 3x plus 2y minus z equals negative 3, and 2x plus y plus 2z equals 3. And I'm going to number them 1, 2, and 3. Again, that's just the system I'm using. You can use any method that you prefer to use. Okay, now when I look at this, I can already see that if I add 1 plus 2, then I eliminate z in these two equations. So let's add equation 1 plus equation 2. So we get 4x minus 3x, that is x, and minus y plus 2y is y, and z minus z is 0, so we can write 0 here, and that's equal to 6 minus 3, which is 3. So now we have an equation that says x plus y equals 3. So now we have one equation and two variables. Now the next step is kind of optional. Again, there are different ways to do this. But if I look at this, it tells me that if I multiply equation number 2 by 2, I get minus 2z, and here's a plus 2z. So again, I can eliminate z. So I multiply equation 2 by 2. So 2 times equation 2 would give me minus 6x plus 4y minus 2z equals minus 6. So that's equation number 2 multiplied by 2. That means I multiply each term by 2. Minus 6x plus 4y minus 2z equals minus 6. And then I will add to this equation now equation number 3. So plus equation number 3. Equation number 3 is 2x plus y plus 2z equals 3. So now when I add these two equations, I get minus 6x plus 2x is minus 4x. And 4y plus y is 5y. And minus 2z plus 2z is 0. And minus 6 plus 3 is negative 3. So that now gives me the equation minus 4x plus 5y equals negative 3. So now I have a system of two equations. And it's pretty easy to work with that. When I multiply the first equation by 4, so multiply this one by 4, I get 4x plus 4y equals 12. So when I add these two equations now, 4x minus 4x plus 4x is 0, and 5y plus 4y is 9y, and minus 3 plus 12 is 9. So now I can divide both sides by 9, and y is equal to 1. Using the equation here with y equals 1, we have x plus y, so x plus 1 equals 3, so x equals 2. And then we can use any of the other equations. Let's say one of the original equations. Let's use equation number 1 to determine what z is. So equation number 1 is 4x minus y plus z equals 6. So now we replace x with 2. So 4 times 2 is 8. And y is equal to 1, so minus 1. Plus z equals 6. So that was equation number 1. I replace x with 2, so 4 times 2 is 8, and y is equal to 1, so minus 1, plus z equals 6. So 8 minus 1 is 7, plus z equals 6. So that means that z is equal to negative 1 when we subtract 7 on both sides. So the ordered triple 2, 1, minus 1 is the solution of the system of three equations and three variables. So let me just write it next to it. So here's the original system of equations, and so the triple 2, 1, minus 1 is the solution to this system of equations, and I leave it up to you to verify that this is the correct answer. So let's do the next one. So here with equation number 1, 2x plus y minus 4z equals 0. And equation number 2 is x minus y plus 2z equals 5. And then equation number 3 is 3x plus 2y plus 2z equals 3. And again, I can see right away when I add equations 1 and 2, I eliminate y. So let's add equation number 1 and equation number 2. and we get 2x plus x would be 3x. And y minus y is 0. And minus 4z plus 2z is minus 2z. And 0 plus 5 is 5. Also, I notice that I can eliminate y from the third equation. If I multiply the second equation by 2, I get a minus 2y, and then it'll cancel out the 2y here. So let's multiply equation number 2 by the number 2. So 2 times equation 2. That'll give me 2x minus 2y plus 4z equals 10. And now I'm going to write the equation number 3 underneath it. 3x plus 2y plus 2z equals 3. So that means I now have, when I add these two equations, so this was equation 1, I get 5x plus 0y, or plus 0, plus 6z equals 13. So let's look at the two equations in two variables now. We have this one here, 3x minus 2z equals 5. And the other one in two variables is 5x plus 6z equals 13. So now I just have two equations and two variables. And again, we know how to do that. We know how to solve that system of equations. For instance, if I multiply equation A by 3, I get a minus 6z. If I add that to equation B, then I eliminate z, and I only have x left. So let's multiply A times 3, so 3a. So we get 9x minus 6z equals 15. So when I add these two equations here, I get 5 and 9 is 14x. The z's cancel out, so plus 0. And then 13 plus 15 is 28. So now I divide both sides by 14, and then x equals 2. So when x is equal to 2, I can use one of the other equations, let's say this one here, to determine what z is. So we have 3 times, let's use A, equation A, and substitute x equals 2. So we get 3 times 2 minus 2z equals 5. So 6 minus 2z equals 5. When I subtract 6 on both sides, I get minus 2z equals minus 1. Now divide both sides by negative 2, and then z equals 1/2. So now I have 2 of the 3 that I'm looking for. And let's just use equation number 1. The original equation number 1 was 2x plus y minus 4z equals 0. So we replace x with 2 and z with 1/2. So 2 times 2 plus y minus 4 times 1/2 equals 0. So 2 times 2 is 4 plus y. and minus 4 times 1/2 is minus 2. That equals 0. In other words, 2 plus y, 4 minus 2 is 2, plus y equals 0, or y is equal to negative 2. So now we have our order triple. X equals 2, y equals minus 2, and z equals 1/2. So that's the solution to the original system of equations that we had here. So the solution is the order triple, 2, minus 2, and 1/2. And I leave it as an exercise for you to verify that this is the correct solution. The last exercise is a guided solution. Solve the system of equations x plus y plus z equals 100, x minus y equals minus 10, and x minus z equals negative 30. So how do we go about this? Well, when we add 1 and 3, get x plus y plus z equals 100, and x minus z equals minus 30. So that means x plus x is 2x plus y, and 100 minus 30 is 70. So that's one equation and two variables. When we add 2 and 4, in other words, x minus y minus 10 plus the one that we just had, so we get x minus y equals minus 10, and 2x plus y equals 70. So because we know then that eliminates y, so then x plus 2x is 3x. And minus 10 plus 70 is 60. Dividing both sides by 3 means that x is equal to 20. Now we substitute 20 for x in equation number 4 and then solve for y. So 2 times x is 2 times 20 plus y equals 70, was from this equation here. So that means y equals, well, 70 minus 40, 2 times 20 is 40, so y equals 30. And then using equation 1, with x equals 20 and y equals 30, we simply get 20 plus 30 plus z equals 100. So in other words, z is equal to 50. 20 plus 30 is 50, subtracting 50 on both sides, and 100 minus 50 is 50. So in other words, the numbers check, and the solution is the order triple, 20, 30, 50. This was a little bit faster than the other examples, and that's because the three equations were relatively simple. The elimination worked very easily, very well here, so that's why this was a pretty good one, pretty quick one. But again, to get good at this, it just takes practice, and the more often you practice these kind of examples, the better you'll get at it. It's simply being really focused, and it's just going to take a little time to be able to do that. But you can do this just repetition, repetition, repetition. Section 3.6 is about solving applied problems with three equations. And the first example, the first exercise is triangle measures. One angle of a triangle is twice as large as the second angle. The remaining angle is 20 degrees greater than the first angle. Find the measure of each angle. So it's a good idea to begin with a sketch so we can visualize what we have. Let's say this angle A, measure of angle A, this is measure of angle B, this is measure of angle C. So let's start out by knowing what we know about triangles, and that is that A plus B plus C is equal to 180. You know, the sum of the interior angles of a triangle is equal to 180. Then we know from the problem statement that A, the second angle, is twice as large as its, one is twice as large as the second angle. So let's say, so then A is equal to 2B, and then the third angle is 20 degrees greater than the first, so A plus 20. So we're going to write these three equations in standard form. And so that'll look like A plus B plus C equals 180. And then A minus 2B equals 0 from the second equation. And then from a third equation we get minus A plus C equals 20. Okay, so now we can work on elimination here to isolate the variables. So when I add equations 1 and 3, so 1 plus 3, I get A minus A is 0, and B plus 0 is B, and C plus C is 2C, and 180 plus 20 is 200. Also, when I add equations 2 and 3, 2 plus 3, A minus A is 0, and then I have minus 2B plus C equals 20. So now I have two equations and two variables, B and C, and if I multiply this equation times 2, I get 2B plus 4C equals 400. And now when I add these two equations, minus 2B plus B is 0, and C plus 4C is 5C, and 20 plus 400 is 420. So when I divide both sides by 5, then C is equal to 84 degrees. And using, let's say, this equation here to determine what B is, I find that minus 2B plus C, which is 84, equals 20. So when I subtract 84 on both sides, I get minus 2B equals minus 64. And when I divide now by negative 2 on both sides, then B is equal to 32 degrees. And using the first equation, A plus B plus C equals 180, or we can use maybe the second equation, A minus 2B equals 0. So we have A minus 2 times 32 is 0. So A minus 64 equals 0. So in other words, A equals 64 degrees. So then the three angles, the order triple for which this is a true solution, would be 64 degrees, 32 degrees, and 84 degrees. So 64 degrees, 32 degrees, and 84 degrees. Let us look at another application problem. Here it's about client investments. Kaufman Financial Corporation makes investments for corporate clients. 1 year, a client received $1,120 in simple interest from 3 investments that total $25,000. Part is invested at 3%, part at 4%, and part at 5%. There's $11,000 more invested at 5% than at 4%. How much was invested at each rate? So then it's broken down here. Let X be the amount invested at 3%, Y the amount invested at 4%, and Z the amount invested at 5%. Complete the following table to help in the translation. Okay, so here's the table, and let's just complete it. It's mostly filled out, but let's just do the rest. So here's the first investment of X dollars at 3% for 1 year. They will produce an income or an interest rather of 0.03 times X. The second investment, Y dollars at 4% for 1 year, would yield an interest of 0.04 times Y dollars. And the third amount, Z, invested at 5% after 1 year would give us or would yield an interest of 0.05 times Z. Then the total amount invested is $25,000. And we know that the total interest is $1,120. Okay. So let's write the equations, and then we can go ahead and solve them. So first of all, we know that, let me move it up a little bit here, that X plus Y plus Z equals 25,000. That's a total amount invested. Then we are told that that there's $11,000 more invested at 5% than at 4%. So in other words, Z is equal to Y plus 11,000. And then we have the interest, and that's the third equation, 0.03x plus 0.04y plus 0.05z equals 1,120. Okay, so let's modify these equations a little bit so they're easier to work with. So what we can do is we can, we rewrite as x plus y plus z equals 25,000. So we don't change that. But here we bring the y over, we subtract y on both sides. So minus y plus z equals 11,000. And let's multiply the third equation by 100 to eliminate the decimals. So we get 3x plus 4y plus 5z equals 112,000. We can see right away that y is an easy variable to eliminate. For example, if we add 1 and 2, then we get x plus 0 is x, y minus y is 0, and z plus z is 2z, and 25,000 and 11,000 is 36,000. So we got a very easy equation here, x, I'm going to write it over here, x plus 2z equals 36,000. Okay, next let's think about eliminating y in the third equation. So if we multiply the second equation by 4 and add it to the third equation, then we get 3x. Well, let's multiply the second equation by 4. So 4 times the second equation. That'll give us minus 4y plus 4z, and 4 times 11,000 is 44,000. And then we add that to the third equation. The third equation is 3x plus 4y plus 5z equals 112,000. So when we add these two equations, we get 3x and 0y, and we get 9z, and that's equal to 156,000. So we have 3x plus 4z equal to 156,000. So when we look at these two equations now, let's say a and b, by multiplying the equation a by -3, we can eliminate the 3x. So minus 3 times equation a gives us minus 3x minus 6z minus 108,000. So now we add these two equations, and the x's drop out. We have 3z equals 48,000. So that means dividing by both sides by 3, that z is equal to 16,000. So we can use one of the other equations, like this one here, to determine what x is. So x plus 2z, 2 times 16,000, equals 36,000. So it means x is equal to 2 times 16,000 is 32,000, and 36,000 minus 32,000 is 4,000. And from the original equation number 1, x plus y plus z equals 25,000, we find that 4,000 for x plus y plus 16,000 for z equals 25,000. So that means that 4,000 and 16,000 is 20,000. So that means that y is equal to 5,000. So in other words, the amount x invested at 3% is equal to $4,000. Y, the amount invested at 4%, is equal to $5,000. And Z, the amount invested at 5%, is equal to 16,000. So this concludes section 3.6.